So today we're going to talk about a composition of transformations. So composition just means we have multiple transformations happening at a time. Sometimes it's just multi-step. Sometimes it means another transformation will actually happen. So we're going to look at a couple different examples here. But really this is just applying everything we've learned so far. Okay, so here's the first one. Example, triangle ABC with the vertices as such is first translated by the rule xy maps to x minus 6, y minus 5. And then its image, triangle A prime, B prime, C prime, is translated by the rule xy maps to x plus 8, y plus 3. All right, so let's just first start by plotting our original triangle. Okay, I'm going to do this in green. So we have negative 1, 0, 4, 0, and 2, 6. Alright, so I paused the video to make my lines a little bit darker there, my points. Alright, so I'm going to go ahead and draw this triangle in. Let me pick my green. And I'm going to go ahead and label my points as being A, B, and C as well. So there's my triangle. We have point A, point B, and point C. Okay, so now it says it's translated by the rule xy maps to x minus 6, y minus 5. So let me grab a new color. Okay, so this tells me my x values need to go left 6 and down 5. So for each of those points, I'm going to go left 6. So 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5. So this is my new A prime. Same thing for B. So I'm going to go down, left 6, 1, 2, 3, 4, 5, 6, and down 5, 1, 2, 3, 4, 5. There's my new B prime. Same thing for C. 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5. Alright, so to make this go a little bit quicker, I made some labels over here. But please notice, and I want to make sure you do this on your paper, you do A prime, B prime, C prime. Okay, so I'm going to go ahead and draw in then the actual triangle itself. Alright, now we have this triangle. Now from this point it says then its image, so my A prime, B prime, C prime, is translated by the rule xy maps to x plus 8, y plus 3. Alright, so from my new points here, I need to move to the right 8 and up 3. So I'm going to start with A. I'm going to go to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. And up 1, 2, 3. Okay, with B, I'm going to go to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. And then up 1, 2, 3. Then finally for C, 1, 2, 3, 4, 5, 6, 7, 8. And up 1, 2, 3. Okay, so let's go ahead and label those points. Now, because I moved A prime, my next one is going to be double prime. So it's just the letter with 2 tick marks instead of just 1. Let's go ahead and draw in our line. Alright, so this was an example of just multiple translations. Okay, it's kind of tedious, I'm not going to lie. It's not the most exciting thing we're going to do. But really that's how it's done, and I just want you to make sure you recognize the notation. Okay, so the first time we moved it, it was with a prime. So C became C prime. And then the second time we moved it, it'd be C double prime. If we moved it again, it'd be C triple prime. Okay, so now let's kind of look at that less graphically and more just at the rules. Okay, so what single translation could we have used in order to go from the first image to the last image? So instead of having to start at the green one, shift to the red, and then go to the blue, how can I just go from the green to the blue? Well, I can look graphically. I can see going from A to A double prime, I can go to the right 2 and down 2. And that's true for all of my points. I can go to the right 2 and down 2. So I do know it's going to be xy maps 2. To go to the right 2, I need to add 2. And then to go down 2, I would need to subtract 2. Oops, sorry, not the best typer. All right, so this is my rule that would allow me to do that all at once. But what I would like you to really notice is looking at that and graphing it and having to count it is just ridiculous. It just takes way too long. But what I want you to look at are the 2 rules that we have over here. Okay, so look at these 2 rules. That was my sad attempt at a star. Okay, so look at those 2 rules. And let's just focus on the x's here. We just focus on the x's. If I were to actually not really combine like terms, but think about my constants. It would go to the left 6 and to the right 2. It would net a positive 2. So just looking at your constants. So there's x plus 2, which we said over here. Okay, now if I looked at my y's, again, just looking at the constants, it says minus 5 and plus 3. Well, that would net a negative 2, so that would be y minus 2. So then that's where we got this. All right, so that would be the rule. This right here would be the rule to allow us to go from that original ABC triangle to A double prime, B double prime, C double prime triangle. So the next question is, what single translation brings the second image, which is triangle A prime, B prime, C prime, back to the position of the original triangle? So what can I do if I'm here at the blue triangle? How can I go back to the green? Well, think about, we just came up with this rule up top here, right? We just came up with this rule that allowed us to move from the first to the last. So if I want to reverse that, I just need the inverse. So xy would map to, instead of x plus 2, I need to reverse that. So it's going to be x minus 2, and then y, instead of minus 2, I would need to add 2. Okay, so not such a big idea, but something that we definitely need to say. All right, so now there's a couple of special compositions I want to go over, and then we're going to look at one other example after that. The first one is a reflection over 2 parallel lines. Okay, so if I have 2 parallel lines here, which I've marked, and then this 5 right here that I'm highlighting is the original number. Okay, that's the original. If I reflect it over the parallel line, notice my 5 is backwards. But then if I take this 5 that's backwards and reflect it again, it's really just a translation. It ends up being in the right order again. Okay, and it didn't move up or down, it just kind of shifted. Okay, so a composition of 2 reflections over 2 parallel lines is equivalent to a single. So in this phrase here, you need to put translation. This blank here, we're looking at a translation. I was trying to make that red, but that didn't work so well. There we go. So it's equivalent to a single translation. Okay, the next one, reflections over 2 intersecting lines. Okay, so we looked at parallel lines first. Now, if lines are intersecting, so I have a 6 drawn here, okay, and I've reflected over 1 line, and then I reflect it again, notice what happens to this number 6. It ends up just being rotated. Okay, so a composition of 2 reflections over a pair of intersecting lines is equivalent to a single, we just talked about rotation. Let's see if I can do this better. Rotation. Okay, now, there's more. The angle of, we're going to do rotation again, so the angle of rotation is blank the acute angle between a pair of intersecting reflection lines. So this is twice or double, either way. Double the acute angle. So in this case here, if this were, say, I don't know, an 80-degree angle, then truly when it rotates, it would be 160-degree rotation. This is, honestly, this really doesn't come up hardly ever. I really want you to be more aware of the fact that if you reflect over intersecting lines, you actually end up getting a rotation. All right. Last example, again, is just multiple compositions. I inserted a table here just to help me organize and make this a little easier for you to follow. I also labeled my points A, B, and C on my triangle if you'd like to do that. But we're going to do these following transformations. First, we're going to rotate 90 degrees, and then we're going to reflect over the x-axis. So we're going to first figure out the coordinates for the 90-degree rotation. Okay, so let's do a 90-degree rotation. So let's figure out A. Currently, A is at 2, 8. So maybe we should review. So xy is going to map to negative yx. That's our rule for a 90-degree rotation, okay? So 8 is at is at 2, 8. 2, 8. So my new point A is going to be at negative 8, 2. Okay, and then B. B over here is at, let's see, 7, 8. 7, 8. So it's going to become negative 8, 7. And then finally, C is at 7, 1. So it's going to become negative 1, 7. All right, so that's my first set of points. So if you want, you can go ahead and plot those as being A prime, B prime, C prime. But really, I want to figure out where it's going to land. So now I want to reflect it over the x-axis. So envision is flipping from, say, this quadrant to down here. Remember, when we're flipping over the x-axis, the x-coordinates are not changing. It's the y-coordinates that are going to change. Okay, so my x-coordinates are going to remain the same. So the negative 8 is going to stay the same, and then I'm going to change the sign on the other one, on the y-coordinate. Okay, same thing here. My x-coordinate is going to stay the same. It's my y-coordinate that changes values. And then last one, x-coordinate stays the same. The y value is now negative. All right, so now we have 3 new coordinates. So I'm going to go ahead and just plot those. All right, so we have the point negative 8, negative 2. Oh, sorry. Let me try that again. So we have the point negative 8, negative 2. Then we have the point negative 8, negative 7. And then we have the point negative 1, negative 7. Okay, so if I draw in my new triangle, okay, we really should probably label our points. We have A double prime. Okay, so A double prime was at that 8, negative 2. We have B double prime. Okay, so that was at negative 8, 7. And then finally we have C double prime. All right, so that there is our first rotation and then reflection. So it rotated here and then reflected down. All right, so you have some more practice with this for homework tonight. On some of these, I had you graph. I try not to do as many of graphing because I know it's tedious. And then a lot of them, you're just going to be listing points. Okay, so it's just a lot of the reviewing the rules and memorizing your rules. If you're still shaky on those, before you even start your homework, just go through your flashcards again. Make sure those rules are solid in your mind.